Good morning, everybody. I'm going to get started here in just a minute and let the folks lead that are fixing to do so. My name is John Bakke. I'm Executive Vice President of Worldwide Field Operations for MarkLogic, and I wanted to spend about a half an hour, 45 minutes, talking to you today about data silos and the technology that's built into this domain that we call big data. How many people have heard that term before, big data? Just kind of level set, okay. How many of you all feel like you could explain what that means in 30 seconds or less? A couple, right? It's a pretty complicated subject because there's a lot of different technology, a lot of different problems that are evolved around the concepts of big data. And I'm going to share with you some practical applicability with a system known as healthcare.gov. Who's heard of healthcare.gov in here? Everybody, right? I hope so. So when I give these talks in Europe or other places, they only know it as Obamacare. If I say healthcare.gov, they have no idea what I'm talking about, so it's interesting. MarkLogic is a company that builds technology around big data. It's a database, and I'm going to talk about that a little bit, and then more specifically about how we helped healthcare.gov save the day at the last minute. To get started, I just want to share some survey results. We've seen some survey data across government agencies, and about half of the respondents of a specific survey that I'm discussing with you right now responded to a series of questions. And one of the biggest problems agencies are having is just the vast number of silos and separated data that exists in their enterprise. And their biggest problems are around bringing that data together and then using it in such a way that helps them achieve their mission goals. So there are a lot of challenges around that, and one of those is around data consolidation. Everybody know what that means, data consolidation? Okay, so if you have an enterprise that evolves over time, agencies have data centers or multiple data centers, and they have data that grows up in information systems that they've implemented years ago, maybe even decades ago. And over time, they continue to build more and more systems. Those operate separately. And then you start having to build systems in between those to kind of bring that together. So data consolidation is an effort that most agencies undergo over a long IT life cycle in order to bring that data together, to get more value out of the data, and then to reduce cost and increase efficiencies. And you should be doing this, right? There's no reason why you shouldn't be, over time, trying to do things that save money for your agency. The problem is that there's a lot of challenges and it takes time. So we have different kinds of data. Most of that data lives in relational databases or unstructured type data like files and messages and things like that. So in order to consolidate that data, you need to kind of bring it into a common format. And in the data world, we call that database schema. So if you're familiar with relational databases, you create a schema. And the schema is sort of a map for how data needs to be formatted, how it works together. And then after a while, you add more systems and you try to consolidate more, bring that data in through ETL processes. ETL stands for extract, transform, and load. And the T is really important there because the T is the expensive part. That's the part where you have to take data that exists in your enterprise and change it so that it matches all of your other data. You lose a lot of fidelity and granularity over your existing data, but ultimately you then have to create more schema, right? And it's an iterative process that goes on over time, and this is a generalization about how these things transpire in the workplace or in the IT life cycle. So that challenge continues in most agencies. The problem is how do they get started? Why do we have to do that? We do that because we start with an OLTP database, which stands for Online Transaction Processing. And that's your normal application schema. If you're running an ERP or a CRM system, that has an OLTP schema. And then we create a warehouse so we can do reporting, right? So if you run reports or do business intelligence in your enterprise, that BI schema comes out of a warehouse. It's a different schema than your OLTP schema. And in order to do that, you have to ETL. Remember, that's expensive. That takes time and it costs money. A lot of very specialized resources have to do the work to make that happen. And that warehouse then starts to evolve itself. And over time, different factions within your agency or even multiple agencies start asking, what can I do with that data that I couldn't do before? and all of a sudden the warehouse takes on a life of its own. And it has additional requirements that make it more and more necessary for each of the subgroups to have their own separate database or data warehouse called a data mart, because it has to go fast, it has to have its own unique requirements. So you started with an application, you built a warehouse so everybody could use it, and then it starts to break down because the warehouse couldn't be everything to everybody. And so the data marts start to evolve, and there's more ETL that goes into that. You start to archive that data, bringing the data into tapes and online media that make it possible for you to keep data for long periods of time. More extraction, more transformation, more load. And then you start to incorporate reference data. Reference data is the data about your agency or your agencies that lives into perpetuity, and then it creates another dimension of the data that you need for the long haul. And it's temporal, right? The price of a stock changes every day. The rate of currency exchanges changes every day, but that's reference data that you need if you're a bank, right? And your agency or your enterprise, they're all the same. They all have reference data that's data about the business at hand, right? And the worst part about that is it only gets you to the year 2000, right? So now you're in the year 2000, and holy cow, over the last 15 years, we have all of this unstructured data, right? We have all these files and messages and data that doesn't even fit into rows and columns that are coming in that you're using. So the TSA is looking at Twitter to find out all of the mistakes that they make at airports, because if you're like me, every time you get double screened at the TSA, you tweet about it because you're mad, and you go around and you complain in the airports, or there's video files that you're using in your enterprise. So all of this unstructured data that has evolved out of internet norms that we're used to has started to come into various enterprises, whether it's an airline, the TSA, public-facing data systems, even healthcare.gov obviously got a lot of Twitter play, as everybody knows, right? So all of that data is starting to create the data enterprise for your agency, and it makes it really hard for you to use old technology to build a big data system to help you solve business problems, right? So, oops, uh-oh. That was my fault. They should only have clicker with 2 buttons on it. Okay, so healthcare.gov had this problem. They were coming into, the law was passed in the early part of the decade, and then there were a couple of years where it could be built and had to go live. And most people think I'm crazy for talking about healthcare.gov and associating it to the company that I work for. The thing is that at 50,000 feet, whether you're watching MSNBC or Fox News or whatever, it all smells up at that level because it's just a system that never got finished on time, right? But how many people have ever built a system that had to get done on a specific date and achieve the exact scope that it was mandated on that exact date for 8 million users to use and then have it tested and running in the cloud? It was a very, very challenging system, and if you've ever done government procurement, federal IT, you know that most systems don't finish on time. They don't finish with the scope that was originally intended by that date. It was an almost unmeetable task. And the fact that it was actually live and running 7 weeks after it was supposed to is actually remarkable. The fact about how MarkLogic is built into the system, I'm going to talk to you about some of that because it really does knock down some of the data silo problems that I was explaining to you just a second ago. Okay. So we started talking to CMS, the Centers for Medicare and Medicaid Services, thank you, I always forget the S, which is a sub-element of HHS, Health and Human Services, right? Several years ago, and they already had an enterprise license for your favorite relational database cartel incumbent, right? They had a big license with them. They were going to go build this system. They had to have live October 1, 2013. And they looked at that and they said, well, we can't solve this problem with that database product. It's too hard, right? They had to build a data services hub, which was going to connect various entities within the federal government, the IRS, Department of Homeland Security, to validate whether users were actually supposed to get health insurance. And that hub was going to be used by the states. So the states were going to come in and get information from the government so that they could enroll people in states like Oregon. Wait, nobody got enrolled in Oregon. In Nevada or other places. And then they were going to build the federal marketplace. This is healthcare.gov. This is the website that you go out and you get your insurance application filled out. And then an identity management framework to do all of the security that was needed for the site. A lot of personally identified information, things that are secret and private to each individual that they didn't want to share, right? So, and then they had state data, right? They had payer data, which is another word for insurance company, generally speaking. And then person data, and then a lot of the other all of the health insurance applications, amongst many other data systems. Okay, so what's the big deal? Well, there were 30 some odd states, dozens and even hundreds of insurance companies and payers that were involved, and then they had a goal of 7 million users. It ended up being 8 million beneficiaries that actually got enrolled. And they had a major data problem to solve. Lots of different data systems that CMS had no control over, no common format, no common schema that they could rely on. There was no way they could get all of the states to agree on a format. They couldn't even get all the states to agree to do it in the first place, right? And so they knew they had to have some other database solution in order to do that. And so they started talking to MarkLogic. They got bids from prime contractors to come in and build it. All of them built on their proposals in Oracle. They were going to go build it in Oracle, and CMS said, hey, wait, we already know that we can't solve this with Oracle because we've done some piloting around it, and you're just not going to be able to do that, so we need you to do MarkLogic. We need you to use MarkLogic for the database. And the reason why they picked MarkLogic was because we're flexible. We allow multiple different data formats to be used to solve one specific data type. So an insurance application for United Health Group might be different than an insurance application from Aetna, but they have a lot of the same data in them, right? So a database that can somehow abstract the differences between both different applications was preferable over one where you had to take apart the applications and build rows and columns and put all that stuff in little ice trays, right? So MarkLogic was the solution that they wanted to leverage. And it just so happens it's a big data database. It's a NoSQL. Anybody heard of NoSQL before? That term ring a bell? Okay. NoSQL is a sub technology under big data. So if you really look at the big data space, there's Hadoop. Everybody's heard of Hadoop, I hope. And then there's NoSQL databases. MarkLogic happens to be the only enterprise NoSQL database because it's used in banks and government and other places where they have really important mission-critical data. So what makes it enterprise? Well, we do everything that Oracle and IBM and Microsoft do to their database. We make it secure. So it runs in major intelligence community systems. It runs at major banks. And we've done everything to the product that's needed in order for those customers to buy the product and then put it into production systems using mission-critical data. ACID transactions, which most databases, it's presumed that an ACID transaction is the way that database is built. But most of the NoSQL technology is not built with ACID transactions. And what it really means is that when a transaction happens in MarkLogic, it is serialized, which means that it happens and it's done, and every other element of the information system knows that it's there and it's guaranteed, right? And I'll explain a story on that in a minute and why that's important. And then high availability and disaster recovery. You expect your information technology that you're putting in your data centers to do those things today. It's 2014. You can't put a product into a production system and not have it be highly available anymore. It's just not an acceptable way. And you can see some of the rest, and I'll explain some of these as we go through. But one of the key differentiators of MarkLogic is that it's a database and it's a search engine at the same time. So it has a search interface instead of a SQL interface, which allows you to build really fast applications using more human language type elements than you would with a typical transactional RDBMS system. And then it's also an applications server, which basically allows you to write algorithms really close to the data to do really fast transactions, search and query back to the client and get the answer you need from very complex data types. Okay. So we told CMS that. They liked that story. They said, but we've never heard of you. How many people in here have heard of MarkLogic before today? Okay. So about half, right? We're getting better. It used to be 1 out of 100. We're getting to be a pretty sizable company now. But so we had to produce references, and you can see them all up there. Most of the branches of the armed services, almost every major intelligence service uses MarkLogic in the U.S. federal government. Every one of the top 10 global banks, major media, Publishing warehouses use MarkLogic exclusively to publish their data out, and then many, many other companies and verticals across. So we had significant qualifications to do this, in spite of the fact that very few people at CMS had heard of MarkLogic at the time. And you have to remember, this was around 2011 and 2012. And at that time, we were just starting with the BBC. The BBC bought MarkLogic to do its 2012 Olympic coverage online. Okay, BBC, never went to that website, but remember it was in London, right? And BBC is a state-run media outlet in the UK. All of the reporters for the Olympics in 2012 were BBC reporters. So they ran all of the stories through the BBC pool and then out to the world. So this website had to be more than just a website for the Olympics. This was the UK's biggest internet event in history, and they had to be able to produce the stories and the content to tens of millions of users in sub-second response time, 2.4 petabytes of data per day coming in and out, and 25,000 users per second hitting it. So this was a major endeavor, and they were succeeding with their tests before it went live. It did subsequently go live and never went down. All those metrics were met, but they were one of the primary reasons why CMS bought it. You'd think that they would have gone to a U.S. government agency, which we had plenty of at that time, but the BBC's use case was very compelling for them. We run the Dow Jones revenue engine, which is the Wall Street Journal's Factiva module, and that's the inbound, outbound revenue exchange between media and finance that you don't see every day. And all of those transactions have to be in real time, very high-end infrastructure in order for the Wall Street Journal to run those revenues. So very, very specific processing, very fast, and it never goes down. It's never gone down in a year and a half since we've gone live. And then MarkLogic is the database under the terror watch list, the U.S. government's terror watch list, the most important terrorist database in the world. And it runs in a clandestine state. You don't have to know where it is or who's running it. You can probably guess. But one of the most important databases that we run, and then now the Health Exchange, amongst many other customers that use MarkLogic for those mission-critical type applications. And they're all big data enterprises. All of those customers run major, major data operations that you don't see in most of the companies that you might otherwise expect to see out in the space. But so why do they pick us? We're the right database platform. We run on commodity hardware, commodity storage. You don't have to buy special appliances to buy our product. So it's really inexpensive to implement. It scales up. It scales down. In fact, at CMS, they had the open enrollment. It went all the way through April 15th. They scaled up. They tripled the number of servers and infrastructure for that scale up. And then as soon as April 16th happened, they scaled it back down to just about 8 or 9 nodes. So they save massive amounts of money because they don't have to have the same infrastructure, and it never goes down during that transition. Very powerful data management, very semantic, temporal, spatial, textual, tabular, anything that you'd think and then some out of a relational database, you get on the outputs, and then on the inputs, you don't have to do all of the ETL that you would normally do in a relational database. You don't have to take all that data, mix and match it, get it into the ice tray so you can make ice out of it. You just put it in one big block, and when you need an ice sculpture, you get an ice sculpture. When you need blocks of ice come out of that, or cubes of ice, you get it, because you can just ask the question in a different way. And then from a flexible data perspective, we kind of talked about that. We can implement services. It runs in the cloud. It runs on Amazon. It runs in CMS's contracted cloud. They're moving to another cloud provider. They're already up and running in that cloud environment, and you can put it on premise. Very, very flexible. And then it's enterprise proven. We've already kind of talked through that, and it's really inexpensive. The amount of money CMS pays MarkLogic for this technology is about 1/10 of what they would charge another major database provider. Okay, so what's the big deal? We did this, right? We took this mosh pit of data, enterprises, states, payers. Many of those are now MarkLogic customers, both states and the payers, and we simplified that so that it could all run in one database. So they all run in one database. It's very simple on how it's executed, and it brings all of that together. You can see the complexity. Some university professor actually said this is the most complicated database project in the history of IT. I don't think so. I think it's really complicated, but I think there are other ones that I can think of that are are more complicated than this, but it's very complex. And in the end, we were able to complete the enrollment. 8 million beneficiaries, over 150,000 concurrent users of the website at any given time. 2,500 transactions, which are heavyweight write transactions to the database, full-length insurance applications to MarkLogic, and zero data loss. Zero data loss. During some of the most difficult times where the Obama administration was in the development center, their chief of staff, Todd Park, who at the time was the CTO, I think he just left that post, or he's leaving that post, when during the most difficult times, the database was up 99.9% of the time, and the transaction load never wavered. It was very high. The network went down early on. I think it was still in the month of October, and the database went down because it was all on network-attached storage, and when you're a database, you still need storage, right? So imagine the network goes down. It was down for 36 hours, and all of the Obama administration and their technical fellows were coming to me. I was the sort of the manager on the ground for MarkLogic, and all of the executives from all the other companies were there. And they said, what are you going to have to do when this network comes back up to fix this, to fix it? I said, well, we're going to start the servers, and it's going to work. And I was hoping I was right. And the reason why it did is because we have ACID transactions. When that last transaction hit the disk and then the network failed, that transaction was committed, and the rest that were rolled back in came in after the servers came back up, and there was no corruption in the database. So if you take another NoSQL database that only commits in asynchronous fashion, which we call base, it's a base transaction system, those data writes are lost, and then the data file is corrupted. And that's why if you go out and read about NoSQL databases, they complain, the users complain about it. And this was a very specific moment where the government came to us and said, hey, this is really working. We thought this was going to take you guys a week to unravel, and literally the systems came up and they were up and running. So really good success story for us. I've got a lot of time to take questions. I think I'm making up for some of the overage of the last group, but if anybody has any questions, I'm more than happy to answer. Right here. The content for the
content that sits in these databases, they're obviously, or not necessarily the healthcare.gov that has customer information, but throughout government, all of those records need to be managed according to schedules with NARA.
Right.
How does that tie in?
So I don't know the specific answer to your question with respect to NARA. I know that NARA is one of our biggest customers, and they actually store the metadata for the archives that they have in MarkLogic. But with respect to how CMS is bound by the limits and the policies of NARA, I don't know the answer to that.
Yes, when your company took over healthcare.gov, what would you say were the two major issues that caused the problem in the beginning that you guys resolved?
I would say that there are 3 or 4 major problems. The first of which was the mandated deadline. Okay, I think we all know that when you have a mandated deadline for a system that absolutely has to go live, that there's going to be trouble, right? There's the laws of project management physics that say that something's got to give, either the scope, the time, or the quality. And in that case, there's just not enough time to test thoroughly the infrastructure that housed healthcare.gov for the live system. They were literally putting it out there on the live cloud system days before, minutes before it was supposed to go live. So it just wasn't tested thoroughly. And most of that testing wasn't really even the application. It was making sure the network was properly configured, the server nodes were properly configured, and they weren't. They just weren't. The network went down. The server nodes were different. Usually when you implement a clustered system that has a lot of servers, you expect each of those servers to basically be configured the same, and they weren't. They kept adding different. There was one point where there were dozens of servers in the cluster where some of them had Red Hat Linux, version X, and then some of them had a different version of the operating system, or VMware vSphere 4.1, and some of them had 5.1. So if there's inconsistencies in the software, there's going to be inconsistencies in the cabling and all of the other things that make just the physical aspect. Many of those things were fixed in the first month after the 10.1 go live date, and that's when things started to get better, right? And so a lot of infrastructure issues that would have been fixed had they backed up 3 or 4 months and said, let's test it for 3 or 4 months, and they just never had time to do that. Everybody wanted them to delay it, but the administration was so politically bound to go live based on all of the fervor and the political aspects of it. There was really no other solution other than to just go live and live through it, right? And then so from a federal contracting perspective, probably interesting to many is it's one of those projects where you had an overseer contract, you had a developer for the data services hub, and then you had a developer for the application, and nobody was responsible to the other. And they all rolled up to CMS, who tried to play the general contractor. And I don't think that worked very well for them. And I don't think it works very well most of the time. And I think that if they had it to do over again, they'd probably come up with a different solution. But that's what it was. So when President Obama appointed his team, Todd Park brought in who we affectionately call the kids, the guys that helped him through the campaign. They came in, and that team became the de facto authority, right? So even though there were contracting vehicles all over the place, they were the boss and everybody followed their direction. So the one thing that I would say they did the best was to polarize the authority of it. And I think that was where, in the end, everything fell apart. There was no single point of authority that could get things done until that day, right? And the urgency just wasn't there. Over here.
Just a quick question about information assurance.
Uh-huh.
All the big data, how did you scale down to so much as data echelon? How did you handle security across the board?
Yeah.
Who could see what and why?
Yeah, so essentially, a lot of the security in terms of the authorization and identification elements were handled through their enterprise identity management infrastructure. And then in MarkLogic, you can actually obfuscate fields in the documents. So you might have an application for insurance that has your social security number. We can actually make that unreadable to everybody except for the applicant. X out the first 7 numbers or 6 numbers of it and only allow the last 4. But the identity management infrastructure authenticated the users and provided them the credentials necessary to see the various things. So at a very high level, that's essentially how it was implemented. Yeah.
Could you talk about the reporting and quality assurance metrics you were relying on in order to move the system forward and to see that things were getting actually better?
Yeah, so there were none up until about the 1st of November, right? Because it was just put it all in there and hope it works, which we know, on a major system, there's no way it's all going to work. There's just so many, it's a house of cards and just one card and the whole thing came undone. But quickly, reporting software, there's a startup called New Relic, and New Relic is an up-and-coming, and they have the ability to instrument the entire information system, databases, server software, the switches, the application servers, the error logs, all of that. And New Relic brought sanity to where there was none, and that was brought in very early. We wrote plugins for MarkLogic. There were already existing plugins for Red Hat Linux and VMware. And very quickly, we were able to see where the errors were coming, and then they would go out, and they would fix those, and they would come back into the next build. So proper instrumentalization of the entire infrastructure was a key to getting it fixed. I think that was one of the big things that helped, something that was completely broken on October 1st be basically working by Thanksgiving.